Hey everybody, we are here to discuss the chain of responsibility behavioral pattern. My name is Dallin Snell, and a little bit later we'll be hearing from Tyler Sorenson. So what is the chain of responsibility? So the chain of responsibility, as I already mentioned, is a behavioral pattern that allows for communications among classes to be defined and described. It's used to process requests in a given system. It allows for loose coupling between or rather among these classes by allowing the handlers to be linked together in a chain so that it can help solve requests. Hence the title. That's why it's called the chain of responsibility, because responsibility is passed out to handlers and those handlers are all linked in a chain. This final bullet point here, I'm just going to go ahead and read because I think it really captures the essence of what the chain of responsibility is. So each request is passed to the first handler, and if that first handler can process the request, then the request is processed. If that first handler cannot process the request, however, then it is passed on to a successor. If its successor cannot process that request, then it's passed on to the next one. However, if it can, then the successor will process the request. And this passing of responsibility continues down the chain until either the request is processed or we reach the end of the chain, which normally, if your request reaches the end of the chain, it is a cause for program termination by the operating system, which is not what we want, but we'll discuss more about that later. So an example of the chain of responsibility would be exception handling. So the picture of the code here that I've got is a Java try-catch statement. I would assume it is something similar in C#, but I haven't really done a whole lot of work in C#, so I'm not really sure. However, what goes on here is, I assume most people, if you've done object-oriented programming, you are familiar with exception handling, so I'm only going to touch briefly on it, and then I'm going to move on to explaining how it fits in with the chain of responsibility. So with exception handling, you can throw an exception. There's division by division by zero exceptions. You have a multitude of other exceptions. There's incorrect parsing if you're trying to go from a string to an int, or vice versa, from an int to a string. Any number of other conversions in between types can cause an exception. And even if you go outside of an array bounds, that generates an exception. So we can put code in a try-catch statement to where if an exception is thrown, it immediately stops the execution of the code, goes to the catch statement, tries to find a matching exception that will handle that exception. If it can't, that's how the chain of responsibility comes into play. So what happens is, for the chain of responsibility, if this catch statement cannot catch the exception thrown, it's passed up to the calling method. So if this is a sub-method that was called by main, then this method would pass up the exception to main. If main has no way of handling that exception, it passes it up. And then if whatever it passes it up to can't handle it, it continues to pass it up and pass it up and pass it up. Well, eventually, we're going to reach the operating system. And if the operating system catches this exception, it'll terminate our program. And like I mentioned prior, that's not really something we want to happen, because then our program crashes, the user can't use our program, it's a big mess. So that is an example of how the chain of responsibility works in a program setting.
Now we're going to talk about some of the pros of the chain of responsibility behavioral pattern. The first pro that we have listed here is dynamic modification of handlers. So a handler is any one of these links in our chain of responsibility. So if we were to dynamically determine how a request will be handled during runtime, that's some place that a chain of responsibility would help us out a lot, because we're able to analyze the runtime data and then form a chain based upon that data. The second pro we have is request sender is not directly linked to request receiver. So during runtime, the actual request sender, so that which is asking for data to be returned, is not directly linked to any one of the links in the chain. The links in the chain are linked to each other and not the sender. The third pro that we have is any number of handlers can be added to the pipeline almost effortlessly. So at any point in time, if we need a separate link in our chain that needs to perform extra logic at the end, we can easily add that from the previously final link in the chain. And we can do that as many times as we want, which is a big pro to the chain of responsibility. So now some of the cons that we have. The first con is handling isn't guaranteed. So whenever we pass a sender to a chain of responsibility to interpret and return data, each one of those links in our chain is dependent upon the previous link to handle the request. So that's one of the big cons, is if one of our links isn't properly handling that request and passing it on to the next link, that's going to fail and we're going to have unexpected results. Another con is each receiver is responsible for passing requests. So this kind of goes hand in hand. So each time we implement a new chain, it's going to have to pass on that request to the next chain, and they're all linked together. And the last con of chain of responsibility is debugging. When we have this long chain of runtime interpretation for how we're going to handle a request, debugging can get quite difficult. Sometimes you end up digging deep and deep and deep into classes, and that can be one of the cons. Not necessarily a reason not to use it, but it's something to be aware of. And some recommendations we have as to when would be a good time to use the chain of responsibility behavioral pattern. The number one would be when we have multiple code paths that need to be defined, which depend upon runtime values. So say we have an object with a flag called isStudent, and it could be true or false. And we have a separate set of logic that we'd like to apply based on if that value is true, and then another separate set of logic that would be executed if that value is false. So this would be a perfect time to use chain of responsibility. So we could link up those two chains of data to that runtime value and be able to perform it dynamically. So anytime we need more than one object to complete a request is another time that we could use the chain of responsibility and give us more flexibility to use as many objects as we need to complete a task. So that's it for us with chain of responsibility. Thank you very much.